Assalamu alaikum everyone. Today we are doing Cambridge IGCSE past papers, paper 4, theory extended, and the code is 062541. I am doing the variant 1, May June 2025, right? In the last video, we solve the question number 1, but in this one we will do the question number 2, right? So let's start with the question number 2. Read the question first. A resultant force is applied to an object moving with velocity v in a straight line. So basically what we have an object that is moving with velocity v, right? Okay. State two different changes to the motion that the resultant force may cause. In this is basically the theory question. Question number 2 is a whole theory question. So in this question, what we want to find out, what we want to tell them the answer, give them the answer. It is the resultant force. Because of the resultant force, what changes in the motion will be occur. So here in how basically in the IGCSE, what we need to do, we need to tell them the answer in a code words, right? The code words are very important. So here how we will find the code words. In the question they give you the mention the velocity, right? So when you give the answer in a changing, like when you give the answer for different change in the motion, you have to tell them within the in terms of velocity, right? So if we have a force that is applying on an object, so what changes will be the velocity in the velocity occur, in the speed occur. So we will know if we have a force, we have a magnitude of the velocity will decrease, increase, may changes. We don't know what it will be, but it will change, right? So we can say magnitude of velocity changes, right? And also the and what is the other change on the velocity is, obviously velocity is not only a magnitude, it's a direction also. So it means direction also changes, right? So direction changes. Again, I am repeating you why we are giving the answer in only velocity. You can also give the answer that there is an acceleration because of the force. That is also a code word. But I am just telling you generally, when you have a question and you find out the specific words, that specific words must be within the question. So you have to read the question again and again and find out the code words from it, right? I hope this is clear. And the second thing is state one other way that the force may change on a stationary object. If our object is not moving, right? In this question what we have to tell them, if our object is not moving, its velocity is 0, it is stationary, but still we have a force on it, right? So what changes will occur? Obviously its shape disturbed, right? Its size changes. So I am writing the shape changes. Maybe it compressed and it deformed the shape, right? Okay, now let's do the question number 3, B part. Wait, I will remove this one. Okay, now read the question number B part. Question number 2, B part. Describe how a uniform meter ruler, a pivot, and a selection of masses can be used to demonstrate that there is no resultant movement on an object in equilibrium. You may include a label diagram in your answer. So I will explain you first with the diagram so you will understand it more clearly. We have a uniform meter ruler. It's mean its center of mass is at the middle, right? And we have to place it on the pivot, right? Then obviously we need to add some masses over here. Capital M, I am writing it, and this one is, let's suppose, small m. I am just generally writing it. This is the pivot point, right? So let's give them the answer. It's a 4 marks question, so you have to give a solid 4 points, right? Solid 4 points. So in the first one is how we will make the setup. It is, we have a place the meter ruler on the pivot. The first point is place not only the meter ruler, center of meter ruler on the pivot. Why? If in the question they ask you we don't have a uniform meter ruler, then you have to add place the center of mass on the pivot, right? But here we know the uniform one is the meter ruler is uniform, so its center is the center of mass. Place the center of meter ruler on pivot, right? Then question part second point is add masses, add mass on one side and balance it, then add it on the other to balance ruler, right? We set it, we explain the setup. Now you give them the formula for the moments. Wait, I will change the color green. Yes, so basically there must be a clockwise movement and anti-clockwise movement, right? So first, again with the third point, we will tell them the movement. The clockwise movement, no, I am first give them the I think we showed them the moment formula. Moment equals to, I hope everyone know, think about what's the formula for the moment is. Moment equals to force multiplied by the perpendicular distance from pivot, right? So here in the question they give you a very equilibrium condition, that there is no movement on the inequilibrium, right? So in equilibrium, what's the condition is, in equilibrium we know that this clockwise movement is equals to the anti-clockwise movement, right? So clockwise movement equals to anti-clockwise movement, right? I am just writing the shortcut, you can write the whole words. So students, I hope this question number 2 will be clear. If you guys have any query, you can comment it, and if you want a private tuition, you can also contact me on this number, WhatsApp 156 271. You can WhatsApp me if you want more discussion. Well, okay students, bye bye.